Hi guys, in this series of videos we'll start by looking at pressure, then we'll learn about Boyle's law, Charles's law, the pressure law, and we'll finish with an exam style question.
So let's start by talking about pressure. So pressure is a force per unit area that is exerted normally on a surface. And here normally means perpendicular, so at right angles too. I'm just going to sketch that quickly. So we've got this box here, and so the pressure on its surfaces would look something like this, where we see these arrows are pointing out of the box, but also at right angles to the surface, so they're perpendicular to it. And we're going to give pressure the letter P. And the other thing we're going to notice is that pressure is a force per unit area. So we want to find the force acting, assuming that there's a constant pressure at every point on this surface, then to find the force on this surface of the box here, let's say this one. So the force on this is going to be given by P times the area of the box. Because there's the pressure is a force per unit area, so we need to multiply it by an area to get the force. So it has the unit of Pascal, but we can realize that that's just really the Newton per meter squared, basically, because we know that it's a force per unit area. The unit of area is meter squared, so it's a force per unit area, so it's per meter squared, and there's a force, so obviously it's just a Newton. Okay, so that's kind of how we write down what pressure is, but what actually is it? So fluids, including gases are fluids too, exert a pressure, and they can be affected by the volume of the container they're in, the mass of the gas in that volume, and the temperature. That is to say, how much gas you've got, how big the volume you're dealing with is, and what the temperature of that volume of gas is as well. And we want to see is that as we increase our volume, so this is going to be our change in pressure is going to go here. So what happens to our pressure? I'm just going to write an arrow. If it goes up, I'm going to draw an arrow going up. If it goes down, I'm going to draw an arrow going down. So as our volume increases, we find our pressure decreases. If we keep these other, so this is going to be if we affect one of these things and leave the other two fixed. So we just increase our volume and don't do anything else. Sorry, that should obviously be temperature at the end there. So we're going to see that as we increase our volume, we're going to decrease our pressure. As we increase our mass, that is, the mass of the gas, and that really just means the amount of gas we've got. The volume of gas means the volume that we're in, the volume of the container. It doesn't mean the volume of the gas we've got, it means the volume of the container we're in. And that's kind of a nuanced difference at this point, but we'll see a bit later what that means. So as the volume decreases, the pressure goes up. Sorry, as the volume increases, the pressure goes down. So as the volume decreases, the pressure goes up. As the mass goes up, the pressure goes up. As the temperature goes up, the pressure goes up too.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.